So when you're working with loops, it can be really useful to trace the loops. And what I mean by trace is that we're going to actually follow the different variables and how they change in value as you go through the loop over and over again, as well as what gets output to the screen. So if we're looking over here at from our practice sheet, this code right here asks how many times the following code will print welcome to Python. So we can trace this. Our variables are count. It's the only variable we need to trace in this particular loop. And in this case, we have stuff printing to the screen. So we will also trace what outputs to the screen. So when we start the loop, before we enter it, we've initialized count to 0. So count is 0, and we're going to compare 0 to 10. 0 is less than 10, so we're going to print welcome to Python. Welcome to Python. I'm not going to write it out loud, but that's going to print to the screen. And then count plus equals 1 means that we're going to increment, we're going to add 1 to our count. So count becomes 1. We're going to come up and we're going to compare 1 to 10. 1 is less than 10, so we enter the loop again, and we're going to print welcome to Python. And we should notice a pattern. Count is going to increment by 1 each time through the loop, and each time we enter the loop, we're going to print welcome to Python. So the next time through the loop, it's going to be 2, we're going to print, then it will be 3, we're going to print, all the way until we reach 10. So 4, 5, 6, 7, 8, and 9 each time. So 1, 2, 3, 4, I'm just counting that I didn't put too many. All right, so we've got each time through, it's going to print welcome to Python until count becomes 10. Because once count becomes 10, 10 is not less than 10, so we will exit the loop, and that will be the last time it prints. So for every count from 0 to 9, we're going to print welcome to Python. So that ends out being 10 times. So this is a nice way to figure out what goes on in a loop, and sometimes it's too many times to be able to actually write out. If this was to 100, we would be looking for that pattern, and that's why pattern recognition is so important. If the loop ended at while count is less than 100, we would note that for every count 1 through 99, we would print welcome to Python. So in that case, from 0 to 9 is 10, so 0 to 99 would be 100, and it would print 100 times. So when you're tracing, you don't always write down every single value, but you would look for that pattern so you can extrapolate forward and figure out how many times it would do. If you're looking, for instance, how many times the loop would execute, you can figure that out. You might be figuring out how many times something will print. You might be trying to figure out how many times some other thing will be executed. So this is being able to trace your loops can allow you to figure that out. So let's look at another example here. So we have what will be displayed when the following code is executed. So if we're going to trace this, again, we're going to take account our variables. And this, again, we just have one variable. We have number. And we also have something printing out to the screen. So we're going to start with number equal to 6 before the while loop starts, and we're going to compare 6 to 0. 6 is greater than 0, so we've entered the loop. So this time we're immediately going to decrement our number variable by 3. Number equals number minus 3, and number is going to become 3, and that's what we're going to print. We're going to print 3. We're also going to, instead of doing a enter, which is the default in print that would go to the next line, this end equals space says stay on the same line and add a space. So actually, there will be a space that kind of prints right here instead of going to the next line on the screen. So we're going to go up and we're going to compare 3 to 0. 3 is greater than 0, so we're immediately going to decrement our number variable by 3, and we're going to print it. So 0 is going to print right up here, one space away from the 3 on the same line because of that end parameter. But now this time when we go up and we compare 0 to 0, 0 is not greater than 0. So we exit the loop at this point. So our answer is C, 3, 0. Let's look at one more example here. So looking at this number 7 right here, we have a k variable that we're tracing. And if you look at the one up above, I encourage you to do that one, and you would need to trace both the sum and number variables. But in number 7, we just have the k. And then, of course, we also have something going on the screen because we have a print statement. So we're going to track k on the screen. So we're going to start with a variable equal to 3, and we're going to check in the while loop while 3 is less than 8. It is, so we enter the loop, and we're going to print 3, and we're going to print 3 squared, which is 9. Now, we don't actually change the value of k over here. We've printed it and we've brought it to the exponent of 2, but we didn't reassign it in the k variable, so we didn't change k at all until we get to this line here where we actually have an assignment. So k is now going to be equal to the initial value of k, which is 3 plus 2, so now we've got 5. So k is equal to 5. We're going to go up. 5 is less than 8. So we're going to print 5, and we're also going to print its square, which is 25. And then we're going to come back up and check. Again, 5 is less than 8. So we're going to add 2. So now we have 7. And then we're going to print 7 and its square, which is 49. And then we're going to increment by 2. So as we come up here, and now 9 is not less than 8, so we've exited this loop, but we have to print this by. There's no control of that. That's just sort of a floating print statement, and so we then print by. If there was a statement here that asked you to print k, k would be equal to 9 at this point. That's the final value of k as we end this program. So you see, tracing gives you a lot of information about what's going on in the loop. You can always do tracing by hand. There is a pretty neat tool at pythontutor.com. That will let you step through your loops and trace them using a web page. So let's get a little bit of a demonstration of that. PythonTutor.com is a really neat website where you can visualize your code. So if you click Visualize Your Code and Get Live Help Now, you can choose, your language. You can choose Java, C++, JavaScript, Python 2. Of course, we're programming in Python 3. And so let's write ourselves a loop here. So let's say x is equal to 5, and then we have a while loop that while x is less than, or let's say while it's greater than 0, we want to print x, and then we're going to say x minus equals 1. So we're going to be decrementing our x value backwards. So what this code should do, if we take a look at this, we're going to start at 5, and as long as it's greater than 0, we're going to print that x value and then go down by 1. So this should print 5, 4, 3, 2, 1. But if this were a more complicated loop that was more difficult to figure out, we could just say visualize execution, and we can step through step by step using this platform here. So we're going to start here while x is greater than 0, and just like we wrote out, x is 5. We're going to go print. So this is, we're tracing the screen. So up here is where we trace the screen, and down here is where we would be tracing the values of our variables. Now x is equal to 4, and then we're back up here where we're checking 4 is greater than 0. So we're going to enter the loop, as we see here, because we've printed 4, and now x is equal to 3. So you can keep tracing through here and see what your loop is doing. And this is a great debugging tool if for some reason your loop isn't working the way that you expected, then you can use this to try to debug and see what's going wrong. So here, 5, 4, 3, 2, 1 is exactly what we expected to happen. And at the very end, our x value is equal to 0. So remember, for any exams, you need to be able to trace these by hand, not being able to use the internet or any external resources. But this can kind of be a good tool for practicing, or for when you're writing more complex programs, to just, figure out some issues that you're having. All right, so let me know if you have any other questions, and happy programming.